All right, well, we're going to talk about the Kelvin temperature scale and absolute zero, which are connected pretty closely. A lot of it is based on what you probably already have knowledge of the Celsius temperature scale. The size of the little notches on the thermometers would be the same. Anyway, we already know, probably from prior knowledge, that the freezing point and the boiling point of water are 0 degrees Celsius and 100 degrees Celsius. And we also probably even remember way back even to elementary school about how motion causes heat from rubbing your hands together, maybe in a little demo in second grade or something. We later learned that it's something called kinetic energy that causes heat. It's actually a motion of a lot of different things. And then we learned further about things like the motion of atoms. I've got a very, very rough diagram of a cadmium atom up here, kind of the 7th grade version, but it's good enough for what we're going to do now. Because what we want to talk about now is the concept of absolute zero, which is the coldest possible temperature in the universe. And that sounds a little bit strange. It seems like you could always turn the thermometer down some. But it turns out that since kinetic energy generates motion, kinetic energy generates heat, then if you have less and less kinetic energy, you'll have less and less heat, until finally you get down to no kinetic energy at all. It's where all motion stops. And at that point, you can't get any colder. You'll notice up in the upper right-hand corner, our atom has stopped. Because you can't get any colder than that, because you can't go any slower than stopped. And so therefore, that's the bottom level of heat. The thing that you need to remember, probably the most important thing of this entire presentation, is that negative 273 degrees Celsius is absolute zero. You will need that to figure out a bunch of other stuff that will be important. All right, so negative 273. All right, and the Kelvin scale, which is the other thing we're going to be talking about, is just about identical to the Celsius scale, with the single exception that the zero for the Kelvin scale is at absolute zero instead of being at the freezing point of water. So 0 Kelvin is the same thing as negative 273 degrees Celsius. So again, identical, except they're basically just shifted by negative 273 degrees. Right. So the other very important fact is that a change in a degree Celsius is the same as a change in a Kelvin. So if you'll notice right here, and this is why it's so important to remember negative 273. If you notice right here, there are 273 notches between that 0 and that negative 273 on the bottom. So therefore, if you already know that 0 Kelvin is absolute zero, you're asked a test question about what is the freezing point of water in kelvins. Well, you already know it's 0 degrees Celsius, but in kelvins, it's also going to be 273 degrees away from the very bottom. And so therefore, the answer to that question will be 273 Kelvin. By the same token, there are 100 notches between the 0 and the 100, between the freezing and boiling point of water. So hey, guess what? There are also 100 notches between 273 Kelvin and 373 Kelvin. So if you're asked what is the boiling point of water in kelvins, it's 373. So that's that much more stuff that you don't have to memorize. The only thing you need to make sure to do is make sure that you're paying attention to whether or not you're being asked Kelvin or Celsius. All right, so wrapping up and summarizing, as long as you understand the rest, there's only two things you really need to remember. And by understand the rest, basically is just where the freezing and boiling point of water are on the Celsius scale. Anyway, only two things you need to remember. Negative 273 Celsius is absolute zero, and it's the same as 0 Kelvin. And also the size of the Kelvin are the same as the size of a degree Celsius. So you've got your reference point where you are with Celsius, and you can just count where you're going with Kelvin with regard to the freezing and boiling point of water, as we just saw a minute ago. So anyway, so like I said, from that you can answer just about any other question you need to answer. And usually most of those questions are going to have something to do with freezing and boiling point of water. And that is it.